Diana Kinaneva and I'm Senior Assistant at the Department of Telecommunication in University of Ruse Angel Kânchev. I have been part of the university since 2008, firstly as a student and now as part of the academic staff. I have started my higher education in the bachelor degree course called Telecommunication Systems, and then I continue my studying in the master degree course in Internet and Multimedia Communication. In 2017, I successfully defended my PhD thesis. Recently, I work as an assistant professor and I teach students various subjects, including communication network and system, routing and switching, converged network, operating system and network protocols, and others. Besides my teaching and scientific work at the university, I work as an expert in several international and national projects. Some of them bring me the opportunity to acquire new skills in the field of 3D technologies. Together with my team, we are doing some practices with 3D scanning and printing. These 3D technologies have become part of our activities during the implementation of a project called Arhiv. The project was about digitalizing and popularizing cultural heritage from Roman times, with the main goal of preserving historical significance. We have managed to digitalize many artifacts by using professional 3D scanning techniques, and then we use 3D printers to create miniatures of these artifacts. Since then, we have managed to gain good knowledge in the field of 3D technologies and decided to embed this knowledge in the educational process. During the implementation of the mentioned project, we had the opportunity to purchase equipment by which we created an extremely modern laboratory used for research and development of new technology in the field of 3D techniques, in two main directions: 3D scanning and digitalizing, and additive technologies for industrial prototyping. Many of our partners, friends and companies around were familiar with our 3D printing activities. They have started to invite us to participate in different projects and activities. Very often our capabilities have been a prerequisite for close relationships with the companies in the region, for which we have performed a number of orders in the field of 3D digitalization and industrial prototyping. During the first months of 2020, the effects of the global pandemic related to the COVID-19 was felt in Bulgaria for the first time. The effect was expressed in several main aspects concerning the state of the market. On one hand, due to the closure of state borders, the sudden suspension of deliveries of goods, materials and consumables from the world's leading manufacturers was palpable. The demand for certain materials and consumables has declined, while at the same time there has been a huge shortage of other supplies that are directly related to the upcoming epidemic of the virus. For example, for a certain period of time, neither the traders nor the manufacturers offered the basic protective equipment on the market, such as disinfectants or masks. In the contemporary economy of the city of Ruse, the light industry branches dominate. They are mostly sewing, textile and food industries. The sewing industry is a branch that leads the economical profile of the city and provides permanent employment. The number of the sewing companies in the territory of Ruse is over 250. To the best of my knowledge, more than 50 sewing companies work with materials supplied by their clients or customers and provide products for markets in Germany, France, Italy and Middle East. The lack of protective masks and the potential market for them at the same time give a sign to the owners of these companies that this is a new market niche and that they can meet this demand by slight modification of their production facilities. The main challenge in front of this initiative is the need to design the manufacturer certain machine elements which in the eventual change of the production lines are the most important components, and their adaptation for the production of multi-layer protective masks must be well considered. The challenge is due to the fact that they cannot rely on factories that produce conventional sewing equipment, because everything has to be happen in extremely limited period of time. Guided by the listed facts, the owners of one of the leading sewing companies in the region contact our team in search of opportunities for possible cooperation and finding a solution for the production of the required machine elements. Within a joint meeting with company representatives, we have discussed all the details and specifications for their needs, and we decided to use the capabilities of modern additive technologies for preparation and implementation of machine parts directly in the production. The main motivation for our decision was the fact that at that moment there is no other alternative solution and the required components must be available as soon as possible in order to start the production. On the other hand, it was expected that in case of possible success, requests for different types and size of mask would appear, which would again lead to the need for a quick and timely response for the manufacturer. Familiar with the possibilities of modern 3D technologies, we had the full attitude for the successful implementation of our cooperation with the company, but before the first test and eventually good results, there was a lot of collaborative work to do between system engineers, CAD designers and our engineers, which are with wide experience in the field of additive technologies. 3D printing, also known as additive manufacturing, is becoming popular with manufacturers. The demand is growing due to some of the revolutionary benefits that it can provide. This production process offers a range of advantages compared to the traditional manufacturing methods. These advantages include those related to the design time and cost, amongst others. 3D printing allows for the design and print of more complex designs than traditional manufacturing processes. More traditional processes have design restrictions which no longer apply with the use of 3D printing. Depending on parts design and complexity, 3D printing can print objects within hours, which is much faster than molded or machined parts. It is not only the manufacturer of the parts that can offer time saving through 3D printing, but also the design process can be very quick by creating STLs or CAD files ready to be printed. The company system engineers and CAD designers have proposed several possible scenarios by which the machines can be adapted to be used for the production of multi-layer protective masks. A thorough analysis have been made and these scenarios were considered in terms of the possibilities of the additive technologies. This led us to a specific decision on how to realize the final machine parts which would be used for the production. The company's CAD designers have developed the CAD models of the machine components. These components are very complex objects and their initial CAD models were not in accordance with some of the features of the additive technologies. They were initially designed in such a way that requires supporting material during the printing. This on one hand increases the time needed for the printing and on the other hand leads to unnecessary use of materials. In the structure of the details, there are inner holes and if the support is generated during the printing, it cannot be removed after that and the details become functionally inapplicable. This feature of the additive technologies have been discussed between the company's CAD designers and our engineers who have experience with 3D printing technology, and as a result, a strategy on how to optimize CAD files to avoid these problems and proceed to the print, the detail and the test have been developed. Tools and fixtures are special parts designed by manufacturing engineers to solve specific problems on the factory floor. Since each tool is often custom-made, they can be extremely costly and time-consuming to make. Creating new tools to replace broken ones means lost manufacturing time, so reducing the time to replace tools can significantly reduce cost. 3D printed tools can be replaced in hours rather than days, and today's high-strength plastics are strong, lightweighted and far less expensive. The three highly used materials in 3D printing are PLA, ABS and nylon. ABS is slightly flexible and stronger, while the PLA plastic comes in several colors and it's biodegradable. But there is a big difference between the three types of 3D printing materials. The shrinkage factor. The shrinkage occurs as the material transitions from the liquid state after melting to the solid state when it is in the occurring process. Managing shrinkage is among the complicated tasks in the 3D printed world. Consider the many involved factors and how each of them affects the others. Shrinkage exists in two forms, linear and volumetric. For the machine elements, the accuracy of their geometry is one of the most important functional characteristics. In order to minimize the impact of the material shrinkage and to achieve satisfactory accuracy of machine parts, a series of experiments were carried out in a temperature-controlled environment. Based on these experiments, the optimal printing parameters for the details were determined. In essence, the details are elements of a production line, and their essential function is to perform the folding of several layers of fabric, and it's supplied to ironing drums, which operates at a very high temperature. The dissipation of the temperature in the working environment led to the absorption and deformation of the 3D printed material. Initially, the materials were used for printing the details was not resistant to a high temperature. In order to ensure a continuous working process of type 24/7, we decided to use ultra-high temperature printing materials like this one, which is glass fiber reinforced polyamide 6 from the series GF30 PA6A. After a series of changes in the CAD files, changing the printing materials and the printing technology itself in terms of setting the appropriate parameters for the printing, a final solution was reached. This fully met the initial expectation and guaranteed the workflow of the modified production line of type 24/7. Thanks to the modern additive technologies, joint activities between CAD engineers and specialists in the field of 3D printing, a product has been created which, due to its unique properties, can be directly integrated into the production lines. The result of this cooperation met the expectation of the company management, which discovered a number of advantages for the use of additive technologies. Thanks to this approach, the company saves time and money and gets the unique opportunity to take advantage of the current demand for the product on the market and thus to valorize their efforts. Using traditional manufacturing techniques, complicated designs were generally more difficult to produce. 3D printing has opened a pathway to the previously unimaginable for designers and entrepreneurs. With the ongoing addition of new printing materials, including metal and fabric, the scope of the adapting 3D printing to multiple sectors is seemingly limitless. Already industries like automotive, energy and aerospace are plugging into the potential offered by the technology, and its presence is being to be felt across the industrial spectrum of the world over. The streamlined processes of 3D printing are speeding up production schedules, and reduced manufacturing time in the long term means reduced energy consumption. Additive manufacturing also produces less waste than many processes, and when it comes to a plastic, these technologies could become a key factor in the drive to clean up our Earth.